Let me check out one more problem. So earlier we dealt with this function g of x, and we looked at the limit as x approached 2 from the left, from the right, and so on. But what if the place that we approach is not at where the cutoff value is? What if we want to find the left-hand limit as x approaches 6 and the right-hand limit as x approaches 6? And then the limit in total as x approaches 6, or even, find g of 6. So let's think about this and how we would go about doing this. All right, so let's do the left-hand limit as x approaches 6 of g of x. We'll take that first. Now, this is going to be easier than you think. All right, when we're around 6, if we're going from the left, although it doesn't matter, then we're really close to 6. And when I say really close, I mean really, really close to 6. So all of our x's are still going to be above 2 when you think about plugging in numbers that are really, really close to 6. So since I'm plugging in numbers that are above 2, I'm just using the expression x squared plus 1. And we're plugging in numbers really, really close to 6. So we know using the algebraic and analytic rules that we can just say that's 37. Well, what if we approach from the right? If we approach from the right, the exact same things happens. Since I'm at 6, I'm well above 2. I'm approaching from the right. So I can just use this expression here, x squared plus 1. And we just saw that when we plug in 6 into x squared plus 1, we end up with a 37. So notice that if we're not close to these cutoff points, then our limit as x approaches a number is going to be basically the same thing as what you get when you plug in that number 6 into the function. Remember that number 6 into the function, I just plug it into x squared plus 1 and get 37. So the point of this is to say all of our previous problems in this section, we were worried about where the cutoff is. And the nice thing is if we're not at where one of these cutoffs is in a piecewise defined function, then to find the limit, I can simply just plug in the number that I'm looking for as long as it's not one of these cutoffs. And so finding the limit is pretty straightforward if we're not at the cutoff values. All right, so that is the end of section 1.4.